And so we are going to hear about these planning-based social patterns for children with autism. And Sara Bernardini, I believe, is going to present. Thanks, David.
Okay, so in this talk I will present a best practice approach to designing and implementing a planning-based virtual agent that can act credibly as a social partner for children with autism and help them to develop social communication skills. So autism is a spectrum of neurodevelopmental conditions that affect three areas: communication, social interaction, and patterns of restricted and repetitive behaviors. But here we just focus on communication, in particular difficulties with both verbal and non-verbal language. So you might wonder why technology for autism. And several studies show that the majority of autistic children exhibit a natural affinity with technology and with computer-based training. Virtual agents are believed to offer particular benefits to children with autism because they can mitigate the anxiety linked with real social interaction. And in particular, we also believe that autonomy carries a particular potential for autism intervention because it eases the demand for one-to-one support from parents and practitioners, and also supports on-demand access that can be very useful for this kind of children that have different sleeping patterns. So our goal was to develop an autonomous virtual agent for these children to help them acquire social skills. And the particular challenges of our applications were linked, of course, to the target user, because we were targeting young children aged 5 to 7, and of course, children with special needs. Also, we were tackling an ill-defined domain, social communication, and also our ambition was to create a system for real-world use and intervention in schools and at home. So here I'm going to describe how we define a set of pedagogical requirements for our agent, because this, of course, was the first step to understand what these children need, and then how planning technology helped us to satisfy these requirements. And I will focus in particular on the technological challenges that we faced and on the lessons that we learned while implementing this application. And finally, I will conclude with an evaluation of the system. So I just want to point out that we built our agent in the context of a full virtual environment that is a magic garden with magic objects that can change shape when the child touches them, and the child interacts with the system through a multi-touch display, and also microphones and gaze tracking. So first of all, the questions that we asked was what social communication skills an agent needs to possess in order to act as a credible social partner for children with autism. And to answer these questions, we organize participatory design workshops with practitioners and children, and also we base our answers on the literature, and in particular the SEARCH framework, which is a comprehensive approach to social communication assessment and intervention. And basically, SEARCH offers an operationalization of social communication, and we, on the basis of that, we define our set of requirements for the agent. So these are the main requirements. The agents need to be able to act both as a tutor and as a peer for the child, and to be able to switch between these two roles when appropriate. And then the pedagogical focus needs to be on social communication in general, but in particular, SEARCH identifies two subcomponents of social communications that are critical, and they are joint attention, which is the ability to share attention with someone else, and also to engage in reciprocal interaction, and symbolic cues, which refers to ability to use and understand nonverbal language. Also, the learning activities that the agent proposes to the child needs to share a unifying theme to support attention, and have this activity needs to be meaningful for the child, and of course engaging. And also, we need a responsive agent, where responsiveness needs to range from physical, from the ability to react to physical actions performed on the agent, to the ability of the agents to respond to the children's changing mental states. And finally, the agents need to offer a positive emotional experience to the child, and to offer a right balance between structure and spontaneity and initiation. So this was quite a challenging set of requirements, but we noticed that actually these requirements are in line with the classical agent theory, whereby an agent needs to exhibit autonomy, proactiveness, reactivity, and social ability. So we explore a number of agent architecture available, and in the end we decided to use the Fatima architectures developed by Diaz and Paiva. And this is because Fatima combines the reactive capabilities needed to obtain a responsive character with cognitive capabilities needed to provide the child with structure and goal-oriented activities, and also social emotional competence, of course, needed to help these children with social skills. So this is the Fatima architecture. As you can see, there are two main mechanisms behind Fatima: appraisal and coping. So the agent experiences emotions based on his appraisal of the external events, and against the backdrop of his own personality. And then the agent deals with this emotion through problem focus and emotional focused coping strategies. And both appraisal and coping work at two different levels, reactive and deliberative. Reactive, of course, affects the short-term behavior of the agent, and deliberative, the goal-oriented behavior of the agent. So at the core of the deliberative layer, there is a continuous partial order causal link planner, and this is, so the partial plans have the usual structures in partial order causal link, and we have a continuous planner so that we can constantly interleave planning and execution, and basically when an intention to achieve a certain goal is created. An empty plan is associated with this intention. Then when the intention is selected as the next one to focus on, alternative partial plans are built until final plans are achieved, and then the best plan is selected for execution, where the best plan is calculated on the basis of the number of steps, the number of open precondition, open causal link, and the probability of success of the plan. And basically, the affective system of the agent works as an heuristic for the planning mechanism, because it's the intention that elicits the strongest emotion to be selected as the next one to work on. And also when the actions are selected, the selection is based on the emotions that the different actions elicit in the agent. So to author Fatima agents, we need to specify this set of features, so set of goals, and in particular there are preconditions that are basically a set of activation conditions for the goal, then success and failure conditions, and the importance of achieving that goal for the agent. Then for the operators, the specification is similar to PDDL, so we have preconditions, we have effects, but probabilities are associated with effects so that we can model uncertainty. And then also there is an additional field that indicates which agent is actually able to perform that action. And this allows us actually to account also for the children action, so that we create a joint action space for the agent and the child. And then we have an affective system in which we have to specify a number of features, the emotional reactions that are rules to determine how generic events are appraised by the agent, then action tendencies that represent the agent's impulsive action to different emotional states, then emotional thresholds that indicate the resistance to feeling a certain emotion, and then decay rates that indicate how fast a certain emotion is going to decay over time. And finally, we have a set of intention, where an intention is composed of a goal, that is the intention to achieve that goal, and then the emotions that are elicited by the desire to achieve a certain goal. So I don't know if the goal is something that is considered complicated for the agent, this can elicit fear, for example, and then a set of plans that are all the plans built so far to achieve that goal. So we specified just the affective system of our agent Andy just once, so that the agent has a coherent personality across the different sessions. And of course, we wanted to create a positive, motivating, and supporting character for the children, and we did that by manipulating emotional reaction rules, action tendencies, thresholds, and decay rates. So you can see here the specification looks like a bit XML format, and here you see that the emotion love has a very low threshold and hunger has a high threshold. So of course Andy tends to be a loving character, and then in this case, for example, you can see that for example, if the user take the turn, this elicits joy in Andy, and so the action tendency, the reaction, is to give a thumb up to the child. So then for each session has a specific high-level pedagogical goal on which we want to focus, for example, engage in reciprocal interaction, and then a number of low-level goals that relate to the particular narrative content of that particular session. So a goal can be fill a basket with flowers in cooperation with the child. And again, we specify this in this XML format. Then, as for these actions, they are all demonstration or trigger for joint attention and symbolic use. And in particular, CERS subdivide these two skills in three subcomponents, which are responding to bid for interactions or initiating bid for interaction and engaging in turn-taking. And Andy is able to perform all these three skills in three different ways: verbally, by using simple language; non-verbally, by using gesture, pointing, and gaze; and also by combining verbal and non-verbal behaviors. So, we specify a number of actions, both in relation to high-level goals and in relation with low-level goals. So first, before going to the evaluation of the agent, I am going to talk about the challenges, as I said, in creating this character. So, first of all, Fatima characters are difficult to author since behavior emerges from a combination of factors. So not only you have to specify the goals, the operator as usual, but also you have to carefully define all the subcomponents of the affective system. And many times you have to really give numeric values per each of them. And so we went through a long process of trial and error because there are no obvious rules, of course, to choose these values. And so we actually are thinking to replace this approach with different approaches, like training character through rehearsal or using a different architecture in which you don't need to a priori author the character. And then also our agent requires knowledge processing on many levels of abstraction. And so the planner produces intelligent behavior in cooperation with other components that are based on different techniques. So we have a pedagogic component, for example, that creates the initial state and the goal for the agent, and also this acts like a drama manager in interacting storytelling systems. So it monitors the unfolding of the story, and it can actually interact with the agent if the interaction between the agent and the child doesn't respect some parameters of optimality in the sense of the pedagogical goals that we want to achieve. Then we have a social communication components that help the planner to interpret the actions of the child from a social communication standpoint. So, for example, if the child gives an object to the agent, the agents need to understand that this is responding to a bid for interaction, for example, if the agent asks for that object. And this has not been done in the planning part, but is done by the social communication component. Then we have a child model that has the role of basically constantly interpreting the complex mental state experienced by the child during the interaction with the agent. And this child model is based on machine learning techniques and tries to interpret both the cognitive and the affective state of the child. And we face significant challenging is putting together all this knowledge in a coherent way, and especially also in the child model component, because it's extremely difficult to assess the mental state of children and also children with autism. Then also our requirement was to provide an unconstrained and spontaneous interaction, real-time interaction between the agent and the child. And we thought Fatima was well suited for that because it interleaves planning and execution and also integrates reactive and deliberative capabilities. But in our case, the external world changes very quickly and unpredictably due to the actions performed by the the child, and so pressured by the high variability of the environment, Fatima constantly formulates new goals and then quickly abandons them. So plans are rarely actually executed to completion, and this is, of course, is problematic. So we are now exploring other strategies like anytime planning or incremental and refinement planning, in which plans are only partially elaborated at first and then only refined when the agent starts executing them. And also some strategy for expectation-based monitoring, so that early signs of plan failure can be captured, and so a new plan can be generated faster. So also in our context, goal management is as important as plan generation, and we have a large number of goals that are also active simultaneously many times, and so in Fatima, the goal selection is determined by the affective appraisal, but this method is not always valid because, for example, we don't want the agent to abandon goals, because if a goal is very important from a pedagogical point of view, it cannot be abandoned. So we are exploring strategies for goal reconsideration and maintenance. So you can, for example, suspend the goal for a period and then trying to resume it at a later stage. And also the final challenge was how we evaluate a plan. The Fatima strategy that selects plan that takes the least time and the highest probability of success is also not well suited for our domain, because plans that have a low probability of success get abandoned, but in our case, to evaluate a plan like this is not appropriate. We want plan metric capable of evaluating the actual pedagogical validity of a plan. So now I'm just going to give very quickly to the evaluation. And so in spite of all these difficulties, we managed to build a fully working prototype. And we developed, we deployed this prototype on 5 schools in the UK. And we worked with 42 children, 19 with autism. We presented the system, the application, for a period of 8 weeks, 3 times per week, with session of 10 to 20 minutes. And we video recorded all these interactions, and then experts in autism annotated all these videos, and also the videos were moderated by a second coder. And we used the search assess protocol to assess our result. Here I'm just focusing on 2 crucial skills that are considered like very important precursors of language, which are responding to bid for interaction and initiation, but we also have results for other social behaviors. So here you see results for the child response to the agent. This is like the first session with the system, an intermediate session, and the last session. So this is not very impressive. This is how many times the percentage of response to agent. But what is more interesting is the percentage of response to the human practitioner. So you can see that across the use of the system, this actually increased. So this kind of suggests that through the system, through the interaction with the agent, the child became more confident and was able also to interact with a human being, which was also was in the room with the children all the time. And then this is actually our main results, that is concerning child initiation to the agent. And so this is skills rarely observed in autistic children. So you can see here an improvement, and also the same here for initiation to the human practitioner. So this is our goal was to build a social partner for autistic children. We created these full working prototypes with good evidence that we had a good result, but still there are many open problems in creating a robust agent architecture for this kind of users. Okay, thanks.